Hello, pre-calculus students. We skipped a section. Now we're going to go back because I think it makes a little more sense to do it now than where it was in the book. And this section is on the unit circle. So as you can see, in the first section, we learned about right triangle trigonometry. But when you have a right triangle, one of the angles is 90 degrees, so the other two have to be less than 90. So we were only dealing with angles in the first quadrant and dealing with triangles. Then we learned that you could do trig values of any angle. We just extended the concept of the triangle into the other three quadrants. Now we're going to combine those, and we're going to come up with the concept of the unit circle. Now the unit circle is called that because it has a radius of 1 unit. So if wherever my angle theta is, I have my x value and my y value, the coordinates on the unit circle, the coordinates of the point on the unit circle are x, y. And you can see that cosine theta being adjacent over hypotenuse is x over 1, or x. So the x coordinate of this point is the cosine of theta. And similarly, the y coordinate is the sine of theta. Here's what I just said. Now, as we go around the unit circle, let's go back to this picture. What's happening to cosine theta? In other words, if we start out here at 0 degrees and we work our way around the unit circle, what's happening to cosine theta, or in other words, the x coordinate, as we go through each quadrant? Well, in the first quadrant, we started at x equals 1, and at 90 degrees, or pi over 2, we were at x equals 0, so cosine theta is 0. As then we went from 90 degrees, or pi over 2, to 180 degrees, or pi, our x coordinate, our cosine of theta, went from 0 to -1. As we went from pi to 3 pi over 2, or 180 to 270 degrees, our x coordinate, our cosine, went back from -1 back to 0, and then in the fourth quadrant, it went from 0 back to 1. So at 360 degrees, or 2 pi, the cosine of theta was back at 1, its maximum. So you can see that the cosine never got larger than 1, never got smaller than -1. Now you try. Please pause the playback and create that last slide, only do it for sine. And I'll show you that answer in class. But try it now. Now there's such a thing, a function that's called periodic. And a periodic function keeps repeating itself. So think about cosine. As we start here at 0 radians, or 0 degrees, we work our way around the circle, and we know that cosine goes from 1 to 0 to -1 to 0 back to 1. Now, once you get to 361 degrees, that's coterminal with 1 degree. 362 degrees is coterminal with 2 degrees. 370 degrees is coterminal with 10 degrees. You can see that this is just going to repeat itself. So t plus 360 degrees, the cosine of that is going to be the same as the cosine of whatever t was. Cosine of 1 degree is the same as the cosine of 361 degrees. Cosine of 10 degrees is the same as the cosine of 370 degrees. So that the graph of the cosine function itself is just going to keep repeating. Well, how long does it take to repeat? For sine and cosine, it takes 360 degrees or 2 pi to repeat. And you'll see that when we actually graph sine and cosine functions. But the smallest period, if you go back to here, what is the smallest value of c such that this will always be true? And that's called the period of the function. In this case, it's 360 degrees or 2 pi. So the period of the cosine function and the period of the sine function are both 360 degrees or 2 pi. When you do period, think copy and paste. Take that function, copy that one period of it, and paste it over here. And it will just, that's what the function will look like. So in the 4 quadrants, you'll notice in the first quadrant, sine is increasing. And then because it reaches a max at 90 degrees or pi over 2. Then the next 2 quadrants, sine, the y value is decreasing, goes down to -1. And then it's increasing, gets back to 0 at the end of 1 revolution around the unit circle. So sine goes from 0 to 2 pi. This is what the graph of the sine function does. Cosine starts at a maximum, so it decreases through the first and the second quadrants, then it increases through the third and the fourth quadrants. So if we look at domain and range, the domain of the cosine function is all real numbers. You can take the cosine of any angle. Think of it on the unit circle. Any angle you want, wherever that terminal side intersects the unit circle, that x coordinate's your cosine. But the cosine itself, so the angle is the input, and you can have any value for the input, so that's all real numbers. The range is the cosine itself, and that's got to be between -1 and 1 inclusive. Same for sine. Now let's say that we want to do something fun, and there's really no reason to do this except to develop. I mean, there's no, real world reason that I could think of to do this. It's just to develop our facility with this, with these new functions, sine and cosine. I want to write the sine of 31 pi over 6 as the sine of a first quadrant angle. Well, a first quadrant angle is going to be a reference angle, because if you think about it, a reference angle is the acute angle, which is a first quadrant angle that the terminal side of an angle makes with the x-axis. So I'm going to take 31 pi over 6, and I'm just going to pull out complete circles. So 4 pi is 2 complete circles, and 4 pi is 24 pi over 6. So what I'm left with is sine of 31 pi over 6 is the same as the sine of 7 pi over 6. And that goes back a few slides ago. Let me find it. Here's a periodic function. I just pulled out I pulled out 2 periods instead of 1 period. And it's still the same. So it's the same as 7 pi over 6. But 7 pi over 6 is not a first quadrant angle. That's 7/6 of pi, or more than 1 pi. Well, pi puts us over here, 7/6 puts us down here. That's a third quadrant angle. So what is its reference angle? Again, a reference angle is the angle that this is our terminal side, because this is 7 pi over 6, or 31 pi over 6 if you want to think of it that way. What is this angle in here that this terminal side is making with the x-axis? Well, that's 1 pi over 6, because pi is 6 pi over 6. This is 7 pi over 6, must be 1 pi over 6. Now we're in the third quadrant. We know sine is negative, so it's got to be the opposite of the sine of pi over 6. So pi over 6 is our reference angle. Last slide. Let's review odd and even functions. Odd functions are symmetric about the origin, and they have this attribute. Even functions are symmetric about the y-axis, and they have this attribute. Turns out sine is an odd function, and cosine is an even function. Let's take a look. Here's angle x, and here's angle negative x. Now you'll notice that let's look at sine. So f of x is sine x. What is the sine of negative x? Well, you can tell it's the opposite of the sine of x. Sine of x is this y value. Sine of negative x is this negative y value. And then if you go over here to the purple angle, the sine of, well, let's see, if this is x and this is negative x down here, the sine of negative x is this value. That's equal to the negative of the sine of x. So this would be the sine of x. This would be the negative sine of x. So sine function is odd. Cosine functions are even. You'll see that the cosine, the x coordinate of these 2 points is the same. So the x coordinate of this point is equal to the x coordinate of this point. Same with these 2 points. If this is x and this is negative x, these two x coordinates are the same. The sine is an odd function, cosine is an even function. That's all I have for you for this lesson. See you in class. Have a great day.